to talk about the graphs of the following three functions and talk about, yeah. Okay. So if you are given r equals 1 plus sine theta, or r equals 2 plus sine theta, yeah, that's the three graphs. Okay. So r equals 2 plus sine theta. Then otherwise r equals 1 plus 2 sine theta, plus or minus maybe, Here I use a positive. So it does not change the shape of the graph, but it changes the orientation of the graph. So for the first one, it looks like a height. Okay. So when theta equals 0, you choose one point here, but the graph looks like a height. Okay. So when theta equals 0, then I is 1. When theta equals pi over 2, you already, let's choose one here. Okay, then this will be 2. Okay. And when theta equals negative pi, okay, when theta equals pi, then this will be just 1. But when theta equals 3 pi over 2, sine 3 pi over 2 is negative. Is negative 1, so that's why the I is going to be 0. So the graph looks like that, because I already knew this looks like a height. So this is a point upward. Okay, so that is the graph. Okay, and here I is always positive. The smallest value for I is when theta equals pi over 3 pi over 2. So when theta equals 0, it's 2. And when theta equals pi over 2, I is 3. So this is 3. So this graph looks like that. Okay. Yeah. Right. So they all point upward, because it's a plus sine theta. And then you have a problem here. When theta equals 0 is 1. When theta equals pi is also 1. When theta equals pi over 2, you get 3. So the graph passing through the 3 points. The only problem is here. Okay. The only problem is here, and there will be twist. So I already explained to you in a similar problem last class. But those are 3 basic pictures. Okay, and you can quickly determine the 3 points. Okay, and then you can draw it. Okay. So now we come to a problem like 1 plus 2 plus sine 3 theta. Okay, sine 3 theta. Okay, sine 3 theta. This is a sine 3 theta is a periodic function. So the period is going to be 2 pi. Yeah, the period is going to be 2 pi over 3. Okay. So this is a similar. I even don't need to choose a special values to choose a points, because I already know this corresponding to that. Okay, because the second part sine theta change. Yeah, but you have to be similar. No, it's not even similar, because the R, it's similar to that maybe. Okay, but you see, this increased pretty fast. Okay, this increased pretty fast. So when theta runs from 0 to the pi over 3, you already completed the whole graph coming back. Okay, so you probably get repeating pictures. I'm pretty sure the picture will be not similar to that one. Okay, so take a look at 2 pi over 3 is where it is 2 pi over 3. 2 pi over 3 is 100. It's 120 degree. Okay, so it's 120 degree. Okay, and right, that's 120 degree. Okay, it's pi over 3 pi, and another one is 4 pi over 4 pi over 3. It's here. Okay. Okay. So you're going to have a complete picture here, then repeat it here, repeat it there. So all I have to do is draw the picture inside this. Okay, inside this. Okay. Then this is the middle line in the middle. Okay. So that is the middle line. Okay. What we did here is it will be, you just compress this graph to put into here. So you can choose a few points. Okay, you choose a few points when theta, 3 theta equals 0. What is r, right? I is going to be 0. Right? I is going to be 0. I is is going to be 2. Okay, so when 3 theta equals pi over 2, and I is going to be 2 plus 1 to 3, right? Then when 3 theta equals pi, and I is going to be 2 again, okay? Right? Yeah. When so 3 theta equals pi is this angle. This is the line. Okay, it's here. Okay, it's a 3 pi. So you already, this is in the middle. Okay, this is in the middle. So it's already goes like that. Okay, it's coming back. Right? This picture. And what I did here is actually I opened this line. Okay, and then I compress it all the way to, compress it. Okay, so from 2 pi to pi to 2 pi over 3. Okay. Okay. All right, now when now when 3 theta equals well, you can choose 3 pi over 2, right? 3 pi over 2. Okay. 3 pi over 2, then this is going to be, I is going to be sine, I'm sorry, this is should be similar to that one, not this one. Yeah, it's 2 plus sine theta. Yeah. Yes, this is 2 plus sine theta, similar to that one. So this never be negative. Okay, this is never be negative. Be careful. Yeah, this never be negative. Okay. Okay. So when it's a 3 theta, then that's gonna be 1. So it's 1. Right. Okay. Then when 3 theta equals 2 pi, right? When 3 theta equals 2 pi, then I is going to be sine, it's going to be 2 again. Okay, it's going to be 2 again. Okay, so that is that is a picture. Okay, so we draw the picture. So this is one section. So all you have to do is just draw the picture so that it's a periodical, right? So the period is 2 pi over 3. And so when theta ranges from 0 to theta 2 pi over 3, okay, that is that you draw that piece is enough. Then it's repeated. Okay, then it's repeated. So the same picture, how can I draw it as the same picture? Right? Yeah, so we have to figure out where it is. Okay, 3 pi. This is a pi over 3, right? Yeah, this will be also pi over 3. Okay, so that's why it's 2 pi over 3 is the whole angle. Okay, and yeah, this will be pi over, then this will be pi over 6. Okay, right? Okay. So my picture here, it looks like that. So this is a high. I'm trying to figure out, yeah, where's 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 this point? Where's this angle? Okay. And this is pi over 6, I think. Yeah, need to go from here. This is a point coming back. Yeah, anyway, you have to find the exact location here. So this is the same like that. Okay, so you repeat it, and then yeah, we just need to find out which angle gives you that point, this tip of the point. So we have to show that sine, when we sine 3 theta equals 1, so 3 theta is going to be pi over 2 when 3 theta equals 2 pi of this, right? And this is sine 3 theta is going to be 1. So that is going to be 5 pi over 2, right? And also when 3 theta equals 4 pi, it's 9 pi over 2, okay? So the corresponding theta is here's pi over 6. The corresponding, this is going to be 5 pi over 6, and that's going to be 9 pi over 6. I simplify a little bit. That'll be 3 pi, okay? 3 pi, yeah, 3 times, yeah. 3 pi over 2, okay? So 3 pi over 2, this is the point. Okay, looks like it. Okay, so you figured out those points, and here's a 5 pi over 6. So this angle should be the middle of this. Okay. Yeah, no. Yes. Okay. So this is how do I sketch the graph. Okay, I draw the graph for the angle from 0 to 2 pi over 3. Okay, from 0 to 2 pi over 3. Then I just copy it and divide the whole circle into 3 equal parts and just duplicate the rest of it. Okay, of course you have to be more precise. It's harder to just duplicate, and you have to point out those special lines, and those special lines, yeah, when the value is going to be, those are special lines. Okay, those are special lines. Okay, when the value R has a maximum, I has a maximum value 3. Okay, so that's probably enough. All right, we're actually going to use this example later to find the length of this closed curve, if possible. Okay. All right. Today's topic is trying to use the Pauli equations, okay, to find the length. Okay, here's a Pauli equation. I equals R theta, okay? Theta may be between alpha and beta. So as long as you give an equation like that, then you get a curve, right? The curve may be not necessarily closed. And this is how do we draw the curve, right? So maybe it looks like that. And this is angle theta. So theta is between alpha and beta, okay? Now for the same curve in the XY plane, right? So X is going to be R cosine theta. So actually you get the parametric equations, okay? Y equals R sine theta, then you get R sine theta and R theta and sine theta, okay? So in order to, this is a parametric equation, okay, for the same curve in XY plane. So ds is going to be dx d theta squared plus dy d theta squared. Now let's calculate that. What is this? You get dx d theta, use a product rule, r prime. I don't want to put the theta here, sine theta, right? Plus minus r sine theta, okay? That's a product rule. And here you get r prime sine theta plus r cosine theta. Okay, that should be d theta. Okay, so you simplify the inside. What you get here is actually is just r prime square, okay, and cosine square theta minus 2r r prime, right? Cosine theta sine theta and plus r square sine square theta. So you get three terms from the first one. The second one, you have r prime square and sine square theta and plus 2r prime r sine theta cosine theta and plus r square cosine square theta. Okay, and you will see that cosine square plus sine square is going to be 1. So actually you only get this. So you don't see sine theta, cosine theta here. So this is the formula you can use. So it's the length of the curve is going to be integral from alpha to beta, and here's r prime square. Okay, so this is a very useful formula. Okay, and we can use that formula when I is constant, right? Then just gives you the area of the you can use that to find the area of the circle, because for the circle, okay, I equals 2, right? Or I equals any fixed number. Okay, that fixed number I call it capital R. Okay. Okay, this is constant. Okay, that Pauli equation describes the circle with radius R, right? And theta is between 0 and 2 pi, right? Then use the formula, the circumference is going to be integral from 0 to 2 pi, and r prime, right? And this is nothing but here's a 0 square plus capital R square. So it's constant. So that's why just r times 2 pi. So that's why you get the circumference, 2 pi r. Okay, so now I'm going to look at another example. We remember our favorite example is 1 plus sine theta, right? Okay, so this is a picture. Okay, looks like that. Okay, I do not, yeah, it should look like a heart. Let me draw a little bit different. Yeah, looks like that. Right. So when theta equals power 2, it's 2 here. And here's 1, this is -1, this is 0, right? The coordinates of the. So I'm very curious about two things. One is what is the area? Second, yeah, what is the parameter of this this closed curve? So theta is between 0 and 2 pi. Okay, so I get a closed curve. Okay. Well, maybe we can evaluate. Okay, maybe we can evaluate. Okay, so what I'm going to do is I write down the formula first. Okay, so the length. Yeah, when you do the exercise, you know, the length. Yeah, write down. So 0 from 0 to 2 pi, and this is r prime s squared plus r squared dc. R prime is going to be cosine theta. I is going to be 1 plus sine theta. Okay, so the question is, can I evaluate this? It looks pretty complicated, right? If you haven't done enough exercise, you were stuck here, you have no clue. Right? Just, oh, that's too complicated. How can I do that, right? But if you did enough exercise, and you will get an idea, at least you can move on, right? So I'm going to simplify this. Okay. Now, if you have those notes on the table, you know, for that section, right? And then if I give a similar problems, you say, oh, I know that. Yeah, look at the solution here, right? So you can just modify the expression a little bit to solve the problem. All right, so let's complete the computations. 1 plus 2 sine theta plus sine square theta. So cosine sine is going to be 2. It's going to be 1. 1 plus 1 is 2. So it's 2 sine theta. Right? Now I have to express as a square. I have to express as a square. But how can I do that? It's 2, 1 plus sine theta. Right? Yeah, how can I express as a something square? So I can get rid of the radical. Well, this is a little bit tricky here. You can try and, yeah, we know sine 2 alpha equals sine alpha cosine alpha, okay? So you let alpha to be half of the theta. So you will get twice 1 plus 2 sine half of theta cosine half of theta. Then you say what? Then what? Can I make it a square? Answer is yes, because 1 is going to be sine, is going to be cosine half of theta square plus sine square half of theta. Okay, so it's x squared plus y squared plus 2xy. So that's why you get cosine half of theta, sine half of theta, and the square. All right, and that's it. Now, the length is going to be the integral from 0 to 2 pi, twice of this. Okay, now be careful. We don't know whether we don't know whether the sum is positive or negative. So the first, it's going to be absolute value of theta. Otherwise, you probably end up with 0. You know, right? Unless you are sure this is definitely positive, but it's not clear to me. Right? It's not clear to me. Right? You have to divide it into, yeah, which one, you know, whether it's positive or negative, right? Right. Okay. Now, when theta is between Yeah, think about that. Theta, half of theta is between 0 and pi, okay? So cosine half of theta could be negative, but sine half theta is always positive. But cosine half of theta may be very negative, right? So the sum is going to be negative. So that's why it's better to divide it into several. Yeah. I just want to know when this become negative, so I can change this, can remove the absolute value symbol when this is going to be negative. Okay. And this is not a trillion, right? So let's divide this into four parts. And this is going to be the integral. Here's cosine half of theta plus sine half of theta. And then from pi over 2 to pi. Okay. And then from pi to 3 pi over 2. And then from 3 pi over 2 to 2 pi. Okay. All right. The first part here is a positive. I can see that it's a positive because half of theta is between 0. You know, even the second one is a positive. Okay, because half theta is between 0 and 2 pi, so it's positive. Now this part is a little bit problem, and here theta is between half of theta is between pi over 2 and 3 pi over 4. Yeah, 3 pi over 4. Okay, over that interval, sine is positive. How about the cosine? Cosine is still is negative, but it's not that too negative. Okay, so this is going to be still positive. Okay, but only when theta is between 3 pi over 2 and 2 pi, which means 3 pi, half of theta is between these two. Okay, then cosine half of theta is greater than sine half of theta. So this is the only problem here. Okay, so you don't worry about the rest of them. That's of the three. Okay, so what I'm going to do is I just put it together again. This is from pi to from 0 to 3 pi over 2. Square root 2, I just write this, and then I have to put a negative sign in front of that. Okay, I put a negative sign. It's a 3 pi over 2 and pi and the square root 2 cosine half of theta and sine half of theta. Okay, then you evaluate. Okay, the antiderivative of that is twice, and here's a sine half of theta. Okay, it's negative cosine half of theta minus 2 square, right? And here's sine half of theta minus cosine half of theta, and 3 pi over 2 and pi. Okay, let's evaluate this. Sine 3 pi over 4, sine 3 pi over 4, sine 3 pi over 4 is positive, right? Yeah, Sine 3 pi over 4 is going to be square root 2 over 2. And the cosine 3 pi over 4 will be negative square pi over 2, so it's positive square root 2 over 2. Then you minus 0, so 0 here, 0 minus negative 1. Okay, that's the first part. And here, if I put the 0, if I put that, it's 2 pi, okay? If I put 2 pi there, and that is going to be 0, right? Cosine pi is 0. Cosine pi is negative 1. Okay, minus 3 pi, it's positive, minus negative square root of 2. Okay, so let's simplify. And here I have a square root 2 plus 2, and here plus 1. And this is a 1. Minus 1 minus 1 minus square root 2. Okay, almost done. Okay, so yeah, so you have multiply this out. It's going to be 4 plus 2 square root 2 minus 2 square root 2 and plus 4. Okay, so it's going to be 8. Great. So that is 8. Okay, so the length of this hut is going to be 8. Okay, so this is very interesting example actually. So the length is equal to 8. 8 means it's connection of the two persons. Okay, you see, look at 8, right? When two identical circles put together, that's 8. It's interesting, yeah. Okay. How about yeah? This is the example. You can also get the length of the graph. We just at the very beginning, we did it, right? And it's the same idea, similar idea, okay? But be careful when you evaluate the integral. Okay, remember the very important formula here is 1 plus sine theta is going to be cosine half theta plus sine half of theta square. Okay. So when you see integral of 1 plus sine theta, you needed to use this identity. Okay, you can verify this identity. Okay. Now, all right, we try to find the area of, okay, we're trying to find the area enclosed by a polar curve. Okay, how to find that? There is no existing formula we can use it and find the area, okay, of the region enclosed by polar curves. So before we do that, we needed to look at this special formula. Okay, this is sector, part of the circle. So the area is going to be half of r squared theta. Okay, right? The whole circle is going to be a equals pi r squared. So now consider the region. Okay, it's enclosed by its r is going to be less than equal to r2 theta, greater than r1 theta. Theta is between alpha and beta. How do I draw this graph? It's going to be like that. Okay. So for the same curve, right? This is the alpha, that is the beta. Okay. So we want to find the formula for this area. So what we can do here is I divide so use a calculus idea. I don't have any existing formula, I can use it because I given two parametric equations, and we don't have any formulas for the area between two parametric equations. For the area of the region between two curves. Okay, so we have to derive a formula, and then so I'm going to divide it into okay. Then I divide the angle into many sub-intervals. Okay. Then I get a small section. Okay. What I'm trying to do is I'm trying to estimate that piece. Okay. For that piece, okay, and if the radius is I is arbitrary, I is between these two, right? I is yeah, I'm going to take R star. I is the value of any theta I star, and I star is between theta I minus 1 and theta I. Okay. So the area of that section is going to be, yeah, the total area is approximated by half of R squared times delta theta I, right? Right? So that is the area of that small section. Then, if you pass to the limit, and then you will get the integral from alpha to beta and half of R theta squared dc. Okay, so that is the area formula. I just show you how do we get it. Now you can find the area of the hut. Okay, so find the area of the region increased by this curve 1 plus sine theta. Theta is between 0 and 2 pi. Okay. So this is a picture again. Okay. So we want to see how big of the area. Okay. Right. So the idea is that, if you derive the formula, you divide them into many slides, right? So you estimate each slide and take a limit. So my formula here is the integral from 0 to 2 pi, half of R squared d theta. That's it. It's for even simpler, right? Even simpler. So there's no radical here. Half of 1 plus sine theta squared d theta. Okay. I'm going to square it. So it's 1 plus 2 sine theta plus sine squared theta d theta. All right, so integral of sine theta from 0 to 2 pi is going to be 0. Okay, what you really don't need it to, you have to find the antiderivative. This is the only problem here, sine squared theta. Sine squared theta is 1 minus cosine 2 theta divided by 2. Okay, then you can find the antiderivative of each term. Okay, 1 and 1/2, let's put together first. Yeah. All right, so let's find the antiderivative. This will be minus 2 cosine theta, and this will be plus minus here, 1/4 sine 2 theta and evaluate the two endpoints. Okay. Okay. So the only non-trivial term is going to be this one, 3 pi over 2 times 2 pi. So I got 3 pi over 2. So that is the area. That is the area. So we can always evaluate the area. Right? We can always evaluate. And similarly, you can do the, you can compute the area of other similar graphs. Okay? Okay, let me look at the next problem. Okay, find the area of the region, right, enclosed by one loop. Okay, you have to determine which loop. Okay, one loop of the curve. So sounds like there are many loops there. R squared equals 4 cosine 2 theta. Okay. So this is a periodical function, cosine 2 theta. Okay, cosine 2 theta. We have to figure it out. Yeah, theta is between, and clearly theta cannot be. You have to make sure this is a positive, right? Otherwise, this question has no solution. So you may assume that this is from negative pi over 2 to positive pi over 2, because only for that interval, and cosine 2 theta is going to 0. Okay. Okay. Otherwise, you're going to have a 2 pi. Okay. This is a continuum, right? This interval, just one interval, actually give you all the information. Now, then you can also, if this is a periodic function, but when you draw the curve, you have to draw the curve in a complete, theta must be run from 0 to 2 pi. So you can also say that it's going to be pi over 2, and another one is 3 pi over 2 and 2 pi. So because the nature of this graph, this is the angle, you have to rotate it completely, right, from 0 to 2 pi. Right? And only when theta is in these two intervals, I is positive, for cosine 2 theta is positive, so you can solve for it. Okay? So you can solve plus minus 2 and cosine 2 theta. Okay. All right. Yeah. So we have to sketch at least one of them. Right? Yeah, it's a little bit difficult to sketch the graph. Okay. So let's draw the graph. When theta equals 0, okay, when theta equals 0, cosine 2 theta is 1, so I is going to be plus minus 2. Okay, so it's 1 is here, other one is here. So you get 2 points at the same time. It's always symmetric, right? When theta equals, I want to say 2 theta, yeah, in the middle, right? 2 theta, it can be, let's say the middle one, pi over 4, right? Then when theta equals, when cosine cosine 2 theta. When 2 theta runs from 0 to pi over 2, cosine 2 theta runs from 1 to 0. So in the middle, okay, that's pi over 8. And that's I is going to be, right, 2 plus or minus 2 square root of, well, this is a kind of positive number. Cosine 4 pi over 4 is 2 square root 2. Okay, anyway, it's kind of positive number. When theta equals 2 theta equals pi over 2, cosine 2 theta is going to be 0. Okay, so anyway, the graph goes like that. Okay, this is a half of the angle, pi over 4. It's decreasing to that point. Okay, and there's a similar ways you get the other side. You also draw this picture. Okay, because I is a plus minus. Now, after you pass, after you know 2 theta, then you stop. You know, you get one this picture. Then you have to theta must be between those two. So this will be 3 pi over 2. Then theta is going to be cosine 3 pi over 2 is going to be 0. So pi over 3 pi over 4. Okay, where is 3 pi over 4? 3 pi over 4 is this thing. Okay, 3 pi over 4 is this thing. Okay, and both I is going to be 0, so don't worry about that. Okay, then you have a angle. Yeah, let's say 2 pi equals 2 pi. Then theta 2 theta equals pi. That'll be pi. That's when theta equals pi. I is going to be plus minus 2. Okay, so that is those are the 2 points when theta increase from here. Okay, so you got 2 points. So the graph still looks like that. Okay, and this is the other side when I is negative. So you get a pretty good idea about the picture. Okay. Now, in order to find the length, you just find the one piece. Okay, the length of the loop, because this by the symmetry, you know, right? So the length of the one loop is just twice of this piece. Okay. So I'm going to, I just need to find the integral. Yeah, one piece. Theta is between 0 and pi over 4, and half of r squared d theta. Okay, and I have to multiply by 2 because I need to get a one loop. Okay, this just from 0 to pi over 4, so only get half of the loop. Okay, so half of r squared is going to be r squared is going to be 4 cosine 2 theta, right? Okay. Then you find the antiderivative. So this is 4. Antiderivative of cosine 2 theta is sine 2 theta divided by 2. Okay. So that is hold on. I have to look at which way. Oh, it's pi over 4. Right? I copied it. Yeah, it's pi over 4. Okay. So that is a 4 over 2. Sine pi over 4 is just only 1. Okay. So the answer is 2. Okay. So the length of a one loop is 2. Yeah, in this section, we only talk about length of the polar curve, and the area includes it's there. We are restricted in a two-dimensional plane. Okay, but for the same curve, you can also use that to, let me say, a couple more words. Okay, so this, okay, for example, this is a curve, right? If it's in, this is alpha here, and that's a beta. Okay. Now you can also rotate it about the x-axis to get a surface, right? So we can here's the point, x and y. So we know that x equals r cosine theta, y equals r sine theta. But this is a polar curve, so I is going to be a function of theta. Okay, so you can set up the area formula, set up integral for the area, okay, of the surface generated by this polar curve about the x-axis. All you have to do is what is the radius r, right? So the area is going to be integral 2 pi r ds. Okay, and then since we get this parametric equations, right? I know that, so I is going to be y is going to be r sine theta, okay? And the ds is going to be, right, dx d theta square plus dy d theta square d theta. And which already know that it's going to be r prime theta square and r theta square d theta. Okay, so put everything here, and you get 2 pi and r theta sine theta. And here is r prime sine theta square plus r theta square d theta. Okay, so you can have this kind of formula. Okay? And you can use one of the loop, you can rotate about the x-axis. You can get to the surface of revolution. Then you can also evaluate the area. Okay, so if this is the loop, right, and the theta is between 0 and the pi over 4, I is going to be, r squared is going to be, right, 4 cosine 2 theta, right? That's what we did. Yeah, cosine 2 theta. Okay, then if you rotate this about the x-axis, you can set up the area. So the area, right? The area, yeah, this rotation is about the x-axis. The area is going to be integral from 0 pi 4 to pi. What is my r? R is the square 4 cosine 2 theta. And here sine theta. And then there's a square root of, square root of, r squared is going to be 4 cosine 2 theta. But then when you differentiate r, right, that's a little bit complicated. So let's see, r is going to be plus 2 square of cosine 2 theta. So r prime is going to be 2, so 1/2 cosine 2 theta. And then you differentiate, that will be negative 2 sine 2 theta. Okay, so 2 cancel out. So you stick it at 4 and the cosine 2 theta, and this is sine squared 2 theta. Okay, and this is d theta. Actually, you can simplify because sine cosine, cosine square sine square is going to be, that is going to be, I don't have a time left. Yeah. So you set up the integral, you can simplify a little bit, okay? And then you can evaluate. The lots of terms can be canceled out, okay? Cosine 2 theta will be gone. This is cosine 2 theta. and you only get the integral like sine theta like eventually. So you can find the area of this. Right? So it's possible the curve is given by Parametric equation, and then you can then you can use set up an integral for the area of surface. Then okay. So let me stop here, give you the quiz.